Let's start by looking at where design technology can take you. Well, if you were to study GCSE design technology, the natural progression would be for you to continue into A-levels. Right here at King Edward School, we anticipate being able to offer A-level product design and A-level design engineering. Post 18, you would then have one of three routes. Let's look at apprenticeships. There are currently 157 apprenticeship providers nationally. That's advertised on the UCAS website. These are degree level apprenticeships. That is where you get the chance to work towards a fully paid university degree whilst training for a high skilled job. Some of the providers include the British Armed Forces, Airbus, BT, Jaguar Land Rover, Rolls-Royce, Toyota. The list is huge and it's growing. You could work within industries such as British Aerospace, automotive design, civil engineering, mechanical engineering, and even something called UX design, which is user experience design. Local apprenticeship providers are Nestle, Land Rover, Rolls-Royce, Toyota and Unilever. This is a great opportunity for somebody who's not sure about going to university but would still like to earn themselves the degree. If you do like the idea of going to university, then the UCAS website currently advertises 1,950 university courses, all linked to design technology. There are many options all over the country, such as Buckinghamshire University and Cardiff University offering architectural design, Loughborough University offering product design and technology. You could do a Masters of Design and Technology Education at the University of Glasgow, or Automotive Design and Motorsport Engineering at the University of Huddersfield. You could even do Games Design at the University of Rotherham. Some people will finish their A-levels and just want to get straight into the world of work. Well, design technology is a subject which is highly regarded by employers. They are looking for people with problem-solving skills, the ability to work on your own and as part of a team. Some of these industries could include carpentry, electricians, plumbers, or even working as CAD engineers. So what actually is Design Technology GCSE? Well, at Key Stage 3, you've rotated through graphic products, product design, fashion and textiles, and food preparation and nutrition. GCSE Design Technology combines three of those areas into one single GCSE. So students here at King Edward's will learn all of the materials at a core level, but you will focus on woods and papers and boards at an in-depth level. It's important to note that food preparation and nutrition is a totally separate GCSE. The examination is split into three parts. They are core technical principles, specialist technical principles, and designing and making principles. At least 15% of the exam will require you to answer questions which are maths based, and 10% of the exam will require you to answer questions which are science based. This written examination will take you 2 hours and it's worth 100 marks, which is 50% of the GCSE. So section A, core technical principles, is worth 20 marks out of a possible 100. This is a mixture of multiple choice and short answered questions. You can see on the slide on the left, the first example is simply a multiple choice question. So the question is, aluminium is used in the manufacture of cooking pots because it has which property? You simply tick A, B, C or D. The answer is thermal conductivity. And students, through design technology and science, and by doing practical work and even looking at how products work, would be able to identify that aluminium is used in the manufacture of cooking pots because of its thermal conductivity. So on this slide there are two further questions, and you can see by reading through the questions that these would require you to demonstrate a knowledge and understanding of both your fabrics and fibres or textiles and your mathematical understanding. Let's look at section B. This is the specialist technical principles and is worth 30 marks. There are several short answer questions worth between 2 and 5 marks and one extended response which assesses a more in-depth knowledge of technical principles. On the example shown, you can see on the left-hand side of the slide there are 6 products and the students would be required to select one of the 6 and then answer questions on their materials and properties. On the right-hand side of the slide, you can see there are 6 manufacturing processes and students will be required to select which of the 6 they know most about. Their response could be through notes or sketches, but fundamentally they need to demonstrate an in-depth knowledge and understanding of a manufacturing process. And finally we have section C. It's designing and making principles. It's worth 50 marks, therefore is the most significant part of the examination. These questions are more advanced and they do require you to draw on skills learnt throughout the course. On this slide you can see that you'll be required to conduct a product analysis and you'll be required to complete a 2-point perspective drawing. So let's look at the NEA. The NEA is worth 50% of the GCSE. It's usually done over a period of about 30 to 35 hours. We will start the NEA on June the 1st, which is the same date as when the exam board releases the contextual challenge, and we'll submit the work approximately in February half term of year 11. So let's have a look at the task. As I've said, the examination board releases the contextual challenges and students will pick one of the 3. So let's have a look at the slide itself. On the right hand side you can see towards the bottom I've discussed why students like the NEA. Well, first of all, it's great because they don't have a final exam which is worth 100%. That releases the pressure from students in the summer. Being able to work at their own pace is really important for some students, and being able to personalise the work, so focusing on something that they enjoy. Being able to apply design skills such as drawing and modelling and CAD, and also being able to make the final product. It's an absolute pleasure. In the centre of the page you can see some examples of work done where students have drawn and sketched, they've used CAD, and they've even rendered their images using programs such as Fusion 360. So what are your next steps? Well, firstly, you could talk to people. You could talk to teachers. You could talk to other students. Discuss this at home. Really important that you find out the answers to your questions. If you do have any questions that you would like to ask but don't want to talk to somebody in person, you could email your questions or queries to myself at nbarrett@keslichfield.org.uk. If you would like to go and have a look at the AQA examination board itself and look through the specification, then I've provided a link below.